Today, I'd like to talk about the new prediction methodology for traffic breakdown. My presentation consists of 5 parts. Let me begin talking about introduction. In many years, traffic congestion has been a serious problem. For example, increasing travel time, environmental impact, and blocking emergency vehicles. Due to these problems, in the research field of intelligent transportation systems, short-term traffic prediction has become a hot topic. And more recently, several deep learning models for predicting traffic congestion and flow have been developed. But deep learning-based algorithms require high computational power, so we focus on obtaining a computationally efficient algorithm. In the next slide, I'll introduce reservoir computing, on which the algorithm of this study is based. Here, I'd like to explain overview of reservoir computing together with physical reservoir computing. Reservoir computing is shown in the figure on the left. The equation is expressed like this. Reservoir computing is an extension of neural networks developed after recurrent neural networks. The difference from the recurrent neural networks is that reservoir computing runs only the readout weights, and the other weights are fixed at random. In physical reservoir computing, as shown in the right figure, we define reservoir state X as the dynamics of the physical system when input is added to the system. Therefore, in this study, we created a model using this concept of physical reservoir computing by considering road traffic dynamics as a physical system. This slide shows overview of model. In our model, we do not consider the input, but define the time series directly observed from the physical system as a reservoir state. Specifically, using these 4 data acquired from the traffic detector in our expressway, we use 100 detectors. The features and advantages of this model are as follows. In particular, the short running time is a key feature. Next, I'll discuss the details of the prediction task. The target of the prediction is the red line of the Hanshin Expressway in Japan shown on the left, and develop a binary classification model to predict whether the traffic congestion occurs after 10 minutes from the prediction time point. The data obtained in the period from April 1st, 2015 to November 31, 2017 were used as training data, and the data from April 1st, 2018 to March 31, 2019 were used as test data. And we created 3 models: autoregression, convolution neural network, and simplified reservoir computing, and compared them with each other. Here, I'd like to explain evaluation method in this study. The following 2 patterns were considered as being able to predict the occurrence of traffic congestion. Pattern 1: traffic congestion that occurs within 30 minutes after the predicted time. For example, the case of prediction was conducted 7:10 and predict to traffic congestion occurrence at 7:20, but the actual beginning is at 7:35. Pattern 2: traffic congestion that actually occurs 5 minutes earlier than the predicted time, as shown in the figure below. From this, it is important to be able to predict that traffic congestion is about to happen before it actually occurs. Here, you can see the result. The upper table shows the overall evaluation of prediction or target points, and the lower table shows the prediction result of 9.0 km point. It shows that the CNN model has the highest F1 value in overall, but the training time for CNN is approximately 1900 times as long as that for SRC, in spite of the accuracy is almost the same. In these figures, the vertical axis indicates F1 value, and the horizontal axis corresponds to the point where the detector is located. The blue bars show the frequency of the occurrence of traffic congestion, and the red point indicates F1 value. The left side is a result of the CNN model, and the right side is a result of the SRC model. The important point here is the area circled in red. This shows that the accuracy of SRC is better than that of the CNN model in several locations, especially in the less congested areas. I'd like to summarize the main findings of this study. In this study, we found that SRC is a light model, but its accuracy is not much different from deep learning if it has a sufficient amount of data. And as a future work, we need to apply SRC to other routes and public roads to check its versatility, and mathematical analysis to investigate how the SRC works well. Thank you for listening.